Okay, this is Kinetics and Equilibrium, Lesson 3, and our focus tonight will be on exothermic potential energy diagrams, and then we will also review potential types of questions that you could see on these energy diagrams. Let's get started. So, exothermic potential energy diagrams, what do we know? We know that they release energy. The product side to the right is always lower than the reactant side to the left, meaning that delta H is going to be negative. So they want us to label the following things. The potential energy of the reactants. So remember, potential energy is always measured from the bottom. So this is our potential energy of the reactants. This is A. The potential energy of the products from the reactant line to the product line is B. The potential energy of the activated complex that goes from the reaction line all the way to the top. That's C. The activation energy of the forward reaction, they have an arrow there for us already, so we'll just label that D. The activation of the energy of the reverse reaction, they have that labeled already, so we'll just label that E. And heat of reaction is always the potential energy of the products, in this case B, minus A, the potential energy of the reactants, which is going to give us this line here in the middle, F. Okay, so let's answer a couple of questions. If a catalyst were added to the above diagram, which letter or quantities would change within the diagram? Well, remember, if I add a catalyst, it's going to do this. Doesn't interfere with the reactant line or the product line. All it does is lower the activated complex. So which letter quantities are going to change? Well, forward activation energy is only going to be from the reactant line to here, and my reverse activation energy is going to be from here to about there. So it's changing quantities D and E. How does the addition of a catalyst change the heat of reaction? Well, heat of reaction is F. Increase, decrease, or remain the same. You can see that it's having no effect on delta H. So that remains the same. And what are the benefits of adding a catalyst? Well, it speeds up the rate. That means that the products can be produced faster. A catalyst is reusable. So those are a couple of good answers. Okay. Now the next two pages you do not have in your notes. We are just going to use these to review. So as I go through the questions, you should be trying to find the answers, and I will pause a moment to give you a minute to think. Which of the letters A through F, so here's A, here's B, I'm going to underline them, A, B, C, D, E, and F. Which of the letters A through F in the diagram represents the potential energy of the products? Potential energy of the products. Hopefully you said E, because this is our potential energy of for the products, from the reaction coordinate up to the product line. Which letter indicates the potential energy of the activated complex? Hopefully you said C. Potential energy of the activated complex goes from the reaction coordinate all the way to the top of the hill. Which letter indicates the potential energy of the reactants? Hopefully you said A. Potential energy reactants goes from the reaction coordinate to the reactant line. Which letter indicates the activation energy? That would be letter B. It's going from the reactant line to the top of the activated complex. Which letter indicates the heat of reaction? Remember, heat of reaction is the difference between the potential energy of the products and the potential energy of the reactants. That would be letter F. Is the reaction exothermic or endothermic? Well, there's two ways to tell. One way is uphill. Anything that goes uphill, potential energy diagram, heating curve, quantum jumps going from a low level to a high level, is always going to be endothermic, and we are going to absorb energy. Which letter indicates the activation energy of the reverse reaction? The reverse reaction. So I'm going this way, so I'm going from here to here, which would be letter D. Which letter indicates the heat of reaction for the reverse reaction? Again, heat of reaction is the difference between the potential energy of the products and the reactants. It's still going to be F. The only thing that changes when we change direction of reaction is whether or not it's endo or exothermic, so the sign. And the reverse reaction, now I'm going from Z to XY, is downhill. And we know anything that's downhill, a cooling curve, an electron jumping from a high level to a low level, or this potential energy diagram would be exo in the reverse direction. Okay, I want to review one more type of diagram. So this diagram has time and it has the potential energy measured in kilojoules, which is often the type that you see on the Regents exam. Sometimes you see questions like the ones that we just answered, but sometimes you'll see ones like this where you have to actually give a value. So the heat content of the reactants of the forward reaction. So when they say heat content, they're referring to potential energy. So the potential energy of the reactants, so that's from here to here, that's going to be 80 kilojoules. The heat content of the products of the forward reaction is about what? So you can see that that's about 160. The heat content of the activated complex. So I'm going from the reaction coordinate all the way to the top and over. That's about 240. The activation energy of the forward reaction. So I'm going from here all the way to here. So it's not 240, okay? It's 80 to 240, which is going to be 160. So you have to subtract the two values, 160. The heat of reaction of the forward. So heat of reaction is the difference between the products. So here's your products, here's your reactants. So it's going to be 160 minus 80 is about 80 kilojoules. And the forward reaction is going uphill, so we know it is endo. The heat content of the reactants of the reverse reaction. So when I go in reverse, everything is opposite. When we go in the reverse direction, these are now my reactants and these are my products. So the heat content of the reactants is about 160. The heat content of the products is 80. The heat content of the activated complex is not changing, so that's 240. The activation energy now is from here to here. So the difference between 160 and 240 is going to be 80 kilojoules. And the heat of reaction, my product line and my reactant line didn't change, so the value is going to be the same, but products 80 minus reactants 160 is going to give me a negative 80. So you can see how here was for the forward reaction delta H, here's for the reverse. The magnitude is the same, but the sign is opposite. And we're going downhill now, so this is exo. Okay, that was just a nice little review of potential energy diagrams. And that's it for tonight. See you tomorrow. We're going to finish up lab.